All right, guys. I'm really happy to see that much people here today because usually we get less people in those events, right? First of all. And second of all, it's really cool to see that much people interested in Swift. And I was just kind of under impression of the last talk. I think I read one blog post that today we're seeing the most of Objective-C developers ever in human history, because every new developer is willing only to learn Swift for his or her Objective-C and Mac career. And what really drives Objective-C to third or fourth top language place in the language rank is iOS, right? So iOS was such a boom, and everybody used Objective-C mostly just because it was the single way to develop the app for the iPhone, right? So that's just something to add. All right, so I guess I would convince maybe some more people to use Swift with, of course, its awesome and great custom operators. I had a special topic for this presentation, a special theme for this presentation, which is the good, the bad, and the ugly, the classic spaghetti western. So first short info about myself. You can call me Mike, and I'm working on iOS since the early days of the platform, since iOS 2.2. That's why I remember why the people start to learn Objective-C. And have around 35 apps in the App Store, and I work with Wire for 2 years now. So what is the operator, after all? Operator is basically the function that calculates from zero or more input values to an output value, which is quite basic. It's just like a function, but it's written differently, right? So the operator has arity. Arity is amount of arguments. So in software development, we know unary, binary, ternary, and who knows, maybe in some day we would see n-ary operators. The operator is having a placement. So prefix operator is placed before the argument, infix between two arguments, and postfix after. It doesn't apply for ternary or n-ary operators. Also, the operator is having precedence or importance. We know that from calculus, we know that multiplication is having higher precedence than addition. This is why the expression on the left is resolved to expression on the right. So we calculate first multiplication, then addition. Otherwise, the expression would be calculated wrongly, right? And the operator is having associativity. So it defines which operation is executed first if all the operations are having the same precedence. So I guess everyone is good with it. We have precedence and associativity. Also in software development, we have overloading. That means that one operator could work with different types of arguments. You know overloading from C++, you know it from Objective-C. No, you don't know it from Objective-C. It's not present in Objective-C. From Swift, of course. And short-circuit evaluation means that, well, a lot of people know that if you evaluate an expression, and if you know already that the expression result would be negative, or if you know already that the expression result would be positive, or you just know that you don't need to calculate the value of other part of expression, it skips this evaluation. It's a certain kind of optimization. So the good, the syntax. Clint Eastwood looks the same, though. So first, I want to introduce a short game. This is the link that you could open to answer the question, and this is the QR code. So please count the usages of operators you see on this snippet of code. It's maybe a bit too big, and maybe a bit too cat-related. But quickly, I can show you the poll results, which I see here. Most likely, Wi-Fi works. Ah, right, exactly. Second letter is I. FIPNQ0. FIP and Q0. It's a bit tough for the beginning, right? I just want to make people wake up and last one is 0, right? Yeah. Guess Wi-Fi is down, right? Or it's not auto-updating. Okay, if it's so slow, we will get to know after. So I will keep suspense, so you could think about this snippet more. Those are the operators that are actually implemented in Swift. So postfix, question mark, and exclamation mark is optional unboxing, and optional force unboxing is an operator. Then casting and type checking as is optional as and forced as is also an operator in Swift. In for loop, in Swift, you do for I in something. In is an operator, and the thing you see between two numbers on the right is also an operator, which is quite neat, right? And the Swift 2.0 try as also an operator, despite the other operators that you know from software development, which are equal, plus, and so on. So I would say that Swift is really flexible with operator definition. The definition consists of two parts. First is the declaration of the operator, how it looks like, the arity, precedence, associativity, right? Also operator, the second part of definition is the function that practically implements the operator. So there could be one definition and several functions for overloading. So you could define equality, for example, and overload, like it's already defined, and you can overload it. And you can use a lot of different characters, actually, for operators that I would look onto in the last part of presentation. So you could use arbitrary UTF-8 characters, which is also quite neat. Yeah, so the operator is defined as prefix, infix, or postfix, operator name, associativity, as we described it, and precedence. Then the practical implementation is just a function that having a name equal to the operator name, and then a set of operands and a return type. Also quite interesting parts are in operand definition. There are auto-closure and no escape. So auto-closure is what we need for short-circuit calculations. Auto-closure would generate the block or closure around the operand, and if you would not want to evaluate it, the closure would not be executed. So you can do whatever you want with this closure. Like if you want to rewrite the logical AND, the second argument would be auto-closure, right? And if you see that the first argument is already false, right? And this is AND, so this means that the whole expression would anyway would be false, and you don't have to evaluate the second argument. Okay, playground time. So I want to show you how I define some operator. Oh my God. Right. I guess I would need a bigger font, right? Oh, this works surprisingly well today. Yeah. So this is the playgrounds. You know them. I defined the basic operator that is making the string uppercase. And you see on the right the results of evaluation. This is fairly basic, you see. So you define the operator as postfix operator. You don't have any. For postfix operator, the precedence and arity doesn't apply. So you just leave the brackets empty. And the practical implementation for a string just gives an uppercase string. If you try to apply it on some other type, it would break. So I guess everyone is on the same page here. Right, this is not a presentation. Also, what is really good with operators is that you could mock or try to pretend that you are doing functional programming and do some functional stuff. So let's say everybody loves Haskell forward pipe. So you could define an operator that would pipe the results of the execution of the functions. So you could do execute several functions in a row using this operator. Like you can do a result, function 1, function 2. So no, first you get to put a value, I guess. Yeah. And this would execute them one by one with the results of the execution of the previous one. Other operator is composition of functions. So the function would be executed one by one with wrapping one in another. Another operator that I just figured out for this presentation is a times operator. So this operator accepts two arguments, one of the number of times you want to execute the closure, and the second one is the closure. And the result is the array of closure execution results. So you see this whole operator thing gives you a lot of flexibility for the language. Though the operators are, as I said in the beginning, same as functions, but using this makes language powerful, I think, despite the fact that nobody understands those symbols. Good. So I guess we're fine with this. This was the good part, the bad part. Usefulness. You might think that a lot of people that were doing the software development for years and years, at the point of time, they were, not as smart, and they never used the custom operators. So maybe there's a reason why the people don't use custom operators that frequently, right? So why there is no such operator before, you might think? Maybe there's a reason for that. Maybe there is a reason that nobody understands this operator in the first place. Maybe there's a reason that it's hard to support the code that uses extensively the custom operators, right? But we still do something like that. And I want to show again another playground. This is what we do, or what we figured out at Wire. One day we were just bored with regular tasks, and we decided that we want to do some attributed strings, right? And of course, first thing that I thought, like, why there is no addition for attributed strings? Why you cannot just add them as normal strings? So just did an operator that does it, which is very basic. Of course, when I added several strings, I want to create the strings with plus equal operator. Of course, I want to use sometimes mutable attributed strings, sometimes normal, sometimes I want to use the normal string that would just have no attributes and be appended to an attributed string. Sometimes maybe I want to add the attributes to a regular string and get attributed string. As you see this in this operator, I overloaded logical AND with the two parameters. On the left it's a string, on the right is the dictionary of attributes. And as a result, you get an attributed string. Yeah, and the same applies for font, color. Yeah, I guess this one is the same as the first one. Anyway, so I think this is fairly clear, right? If you add two attributed strings, you get a concatenation. So even though it's hard to support, and even though some operators doesn't make sense to people, this still adds the readability to code sometimes. Also, the overloading of existing operator could give a hard time for you to debugging, because we don't speak that much about it, but we were doing Objective-C for a really long time, and we have a huge baggage of knowledge for Objective-C. And I guess we don't look at such things in Swift yet that could shoot in your foot. But this is one of the things that actually can shoot you in the foot. Imagine you are using the custom operators in your library, right? Then it appears on the global scope for the library user. So you don't have any namespace for an operator. They are all defined in the global scope. And of course, this could give a hard time for the people who use your library, while they want also to define this operator and this particular overloading arguments. And this, of course, would break hard, and if the user wants to use your library, then the user would have to give up his implementation of a certain operator. So yes, this is kind of a collision. Well, this is not Java, where you would put maybe a namespace identifier in the front of the operator. I guess we want to be more flexible, but this is also comes with the cost. And the ugly. The ugly is the special part of my presentation. So as I said in the beginning, one could use the arbitrary UTF-8 characters, right? But I didn't mention the particular UTF-8 characters that I like. Those are, of course, the emoji. So somebody already understood where it's going. There's some random stuff. So let's say we have a class cat, or struct cat, right? Just a cat emoji is a class name, which is clearly funky, right? And you can also use the emoji in the variable name, right? And you can define an operator that is purely consists of emoji, which is in this case the love sign, right? So let's say if you have a cat class and a love sign, if two cats are making love, they obviously have an array of cats as a result, right? Which is what it does. This all works and runs properly sometimes. I guess this is one of the examples when you shouldn't use really the custom operators and shouldn't use emoji, but still. Yeah, and of course, let's quote the father of Spider-Man. As I said, operators are in global scope. Operators have to be clear. Operators' meaning is like a joke. If it had to be explained, it's a bad joke. And if the meaning of operator had to be explained to developer, it's a bad operator. But in some cases, it gives you a really powerful use of language. And it's definitely a thing that differentiates Swift from a lot of languages. It's definitely the thing that makes the language more flexible. And it's definitely the thing that could be applied in a nice way. So I find several curiosities. Yeah, this one is good because Swift checks actually that if the operator is not associative, then you cannot write two operators in a row with 3 arguments like this, which, of course, if it would be like in C world, it would be left associative. It would evaluate to x equal y equal to z, which would break your code hardly if x doesn't equal to y. That's like say x is true, y is false, and z is false. Then if you would write this expression, x equal to y equal to z, you would expect that they all 3 equal. But in this case, they wouldn't, right? Because the first expression would evaluate to false just because they are different, and the third would be false. And of course, I found a lot of libraries that already utilizes the custom operators. One of them we use is Cartography. This is the framework for creating the UI constraints, where it's basically a DSL, domain-specific language, where you just put equal signs between the parameters that you want to equalize in views. So you say like, this view left equals that view right plus 5 points. So it's very declarative. It's very, very easy to read. Of course, if you create the constraints in zip, it's something that you don't want to look on. But for us who do the UI really hardcore way, doing everything in code, this is the very, very nice part. Euler by Met is the collection of classic mathematical logical operators. Of course, you have to buy a separate keyboard to type them. And swift.go is Go operators implementation. Yeah, that's mostly about it. Have any questions?
I have a question more to the audience. Does anybody know if with Swift 3.0 namespacing for operators is coming? No? I guess it's
this is not that widely known knowledge. But I would like to answer on some question that was asked for the previous speaker, that I think in the new Xcode, like the real problem with Swift 2.0 was that you had to use it to use, if you use new Xcode, you have to take new Swift, right? You cannot use a new SDK with old Swift. That was the problem. Like we all wanted to recompile our application for iOS 9, but we couldn't because we wrote it in Swift 1.2 and it doesn't compile anymore, right? So I guess the Apple is actually thinking about this, and that's why they gave us the way to choose the toolchain, right? So if you would be able to select a toolchain for your version of Swift and then build with the newest iOS SDK, this would be the way to go, right? If you don't want to move to the new Swift version, you just compile with the old toolchain. Well, this all sounds very fancy until you try it, yes, but I guess we all had sometimes a hard time with Xcode, but practically this could work. So,
I have a question to the operators actually. So you use operator overloading. How much problems do newcomers have for that get new to your company? How long do you see code, and I don't know if you do code reviews, but how much of, if you do, how much code do you see where newcomers write, you know, their own method or just don't get it?
So for the recording, the question was how much of the problems we have with the newcomers to understand the operators and code review. This is a good question, actually, because for us, the newcomer actually wanted to put the custom operators in. And we actually did almost the same pull request with this newcomer to add the addition of attributed strings. And this is why, at the point, I understood that adding addition for an attributed string is something that people really need. And this is something that would really be a collision in the namespace. So everybody would add it, and then since then we didn't have any newcomers, so I would keep the audience maybe updated if we would have a newcomer, or maybe somebody would like to join and try this awesome operators thing. Yes?
Yeah, I have more, as a user of many libraries, I have more recommendation for anybody that wants to write their own library for others to use. So if you're doing anything that has any functional aspect to it, like fmap or stuff like that, please don't define your custom operators, because there's no namespacing, as we learned, right? So then, if you define your custom operator in your library, you're screwing everybody else over. So do define the fmaps and whatever you want to do, but don't define the symbols for them.
Yes. This was not the question. This was scream, not a question. Well, I wouldn't. Okay.
The question about the namespacing, so isn't the operator defined only on the new classes you have in your library?
No, you can do the general with the general classes like.
Well, you have the operator that you're so the class, the value that your operator operates on.
Yeah.
But you can do generic stuff.
Yeah.
So you can say any, for example.
Yeah, but then you fuck everyone with.
Yeah, but then to use your operator, I have to conform to your protocol or something like that, right? And there's already established protocols, like like functor, applicative, monad, stuff like that. So again, please don't define your own. I've seen 1,000 libraries that redefine bind or redefine applicative and.
Happy to have a live discussion, really. Yeah, so depends how you define it, right? So if you define it on your own types, it's all safe. If you define the overload or define on wider type, danger.
In your library, just make it private.
Okay.
I think it's funny because so before some years ago I programmed a lot in C++, and there you can do that too. And there the whole community has already kind of rules, unwritten rules, when you do the operator overloading and when you don't do it. And it seems like the Swift community probably has to learn that now. Like all that complicated stuff.
All right. That's what we do basically here. So this is our office building view, just for notice. This is so we have a tours. So this is all our clients running in sync. So this is also quite cool. Of course, I want to put regards for all my fellow colleagues who reviewed the presentation. The one who watched the movie would understand. Yes, this is the references. I like particularly the last one. And yes, so that's it. Thank you very much. And